So
Right.
what we'll do today is I'll demo something on my machine. During the first session we talked about mainly the business intelligence architecture, how different layers of business intelligence architecture are there and why they are there. So how data flows from OLTP database to data warehouse database, and what is the difference of the data model in the data warehouse database versus OLTP database. So we looked at various things. I don't know why this is like this. We then discuss the multidimensional model which is present in the data warehouse. So just quickly go through this because that is important. So if you remember the architecture which is there in this diagram. So you have got OLTP data sources over here, then it goes to data warehouse, and then it goes to the BI presentation layer. So in this area, the data model which is present is normalized, third normalized ER model. But here we cannot use that model because of the query performance which we face, because of the number of joins and all that denormalization which I talked about. So that denormalization and what we call subject orientedness is achieved in data warehouse through multi-dimensional model. But what that model is, how exactly it looks like, that is something which we didn't cover last time. So let me just quickly go through that. Yeah. So this multi-dimensional data model is something which consists of dimensions and measures. I think I introduced the term dimension and measure, right? Just to reiterate that, the dimension is nothing but a set of data items which are used to structure the data, and measure or fact are the items which actually store the data that is to be analyzed. So forgetting the definition, if you just want to put it into a perspective, real life perspective, if you are going to analyze sales data of a typical organization which is a retail or whatever manufacturing, then you look at sales by time, sales by market, sales by products. So the sales becomes fact or measure,
Right.
and everything that comes after this by, those are dimensions. So product, time, market, they all are dimensions. If you just want to have a pictorial view, this is how, and that's why it is called a data cube. Okay, because though it is multi-dimensional, it's not that a cube will always have only 3 dimensions. It can have 4, 5, 6, 7, or even 1 and 2. But generically it is called cube. Doesn't mean that it will have always 3 dimensions. Now, if you just want to compare this model with ER, in ER model you have got entities and relationships. Okay? So both entities and relationships, they are represented through database tables. If it is a one-to-many relationship, then that is represented through foreign key. If it is a one-to-one relation, then it is in the table itself. And if it is many-to-many relationship, then it is decomposed into a separate table. You know that by the pre-normalized form. So just to map that model to this multi-dimensional model, every dimension also has got a table, and every fact also has got a table. Now, what is hierarchy? So hierarchy is nothing but a structured, what you call, organization of dimension data into logical tree. So dimension and hierarchy actually go together. So a measure or fact data is organized by dimensions, but when we say it is organized by dimensions, it is actually organized by hierarchy. So when we say that we have sales data by year, then we can also say that I got sales data by months, quarters, days. So all these elements which are there in a dimension, which have got a parent-child relationship, they form a hierarchy. So in a time dimension, as I also talked, so year is the quarter, then comes quarter, then there is month, then there is a day. So this is called hierarchy. If you take other examples, say product. So if you take a manufacturing industry, then the actual products which the manufacturer sells are the car models. Okay, but these car models, they can be organized into mid cars, sedans, small cars, petrol cars, and diesel cars. So this is hierarchy. Yeah, so these are common dimensions, and then these are common measures, numeric measures. And these actually measures and dimensions, they are organized into something called star schema. Now, star schema and multidimensional model, these two are synonymous terms. Okay, so what is meant by synonymous is star schema is a model which represents the multidimensional model in relational database. See, relational database consists of tables, and tables are of two dimensions, whereas our data has got multiple dimensions. So how do you actually represent that multidimensional data using two-dimensional tables? So that's why this star schema is actually used for implementing the multidimensional model in flat, that is relational databases. And this is how it looks actually. So if you have got a sales table, which is a fact table, you have got four dimensions: location, which is like a market where the products are sold. Then there is a customer, the people who buy the product. Then there is a product which actually gets sold, and then there is a time dimension. So if you look at this sales table, each row of this sales table, like quantity, price, and total, it's going to have four columns which are going to identify that sales quantity or price. And these four columns actually form a composite primary key. So this table is called a central fact table. These tables are called dimension tables, which are at the periphery. And why it is called star schema? It's just that it looks like a star, so it is called star schema. There is nothing more to it than that. So if you have got, say, one fact and then four dimensions, then the star schema will have 5 tables. What it means is that there is one table per dimension, and there is a single join between that table and the fact table. And that join is of 1 to many type. So for each day, there will be multiple fact records in the sales table. For each product, there will be multiple sales records in the sales table. That is this relation. So typically, if you want to define star schema, you can say that it is the simplest multidimensional representation of the multidimensional data, wherein we have one table per dimension, and that one table per dimension has got a single join with the fact table, and that join is of 1 to many. The fact table itself has got a composite primary key. Each part of that key corresponds to the column in the dimension table, and then I explained you that this particular column which is inserted in the fact table is of the lowest granularity. So this time ID in the time table, time dimension, is the ID of the day. Okay. Whereas here the product ID is actually the ID of Okay. So in this sales table, every column which comprises the primary key, it has got one part per dimension. So if there are 4 dimensions, there will be 4 columns in the primary key. And then each column of that primary key corresponds to the lowest level in this. Okay. So in customer, as I said, there are no levels. There is only name and ID. Whereas in location, there are levels. What is the lowest level is the actual location, then there is a region, then there is city, and then there is a state. Just similar to like day, month, quarter, year hierarchy, there is a hierarchy in location. Similarly, there is a hierarchy in product. We have got a product, there is a product type, there is product brand, so that forms one hierarchy. So in general, if there are multiple levels in a dimension, In star schema, we still have a single table, and this single table, as you can see, is completely denormalized. If you were to represent product in a three-normal form, what you would have done is that you would have a separate table for product type, product brand, and then you would include product brand ID into product type, and then product type ID into the product table. Okay, so that is how you would actually denormalize this product table. Or if you have to denormalize location, then there will be a city table, state table, and region table, and each table will have a foreign key into the next level dimension table. But to avoid those many joins, we have got a denormalized dimension table. Okay. And then, as you can imagine, here there would have been 4 tables, 4 joins, and that would be the degrading performance of that. So instead of that, now we have only one single join. Okay. So that is about star schema. Okay. So there is one more variation in dimension model, that is actually for our practical we are going to use this star schema, something similar to what is there in the slide. We are going to have sales data dimension by product, location, time, customers, etc. Oracle has given a sample database which is something similar to this that we will use for our demo purpose. Now the other variation of this star schema is called snowflake schema. What is meant by that? So if you have got multiple levels in a particular dimension, you still can go for normalization of that dimension table. Now it completely depends on how many values you have in the dimension table. For example, in the time dimension, if you have got data for say 5 years, then at the max you will have 5 years, 5 into 12, that is 60 months, and then for each year there will be 365 days. So maximum there will be few thousand records in this time table. Whereas in product table you cannot predict something like this. If it is a 4-wheeler manufacturing company, then the number of records in product table would be less. But if it is a company something like 3M, which produces some stationery material and huge number of products, then the number of rows in this table will be very large. Okay, and then generally the reporting will not be done at a granular product level. For example, 3M sells sticky notes, right? These sticky notes are available in variable sizes, variable number of leaflets in the bunch, then various colors. Generally revenue is not calculated at those granular levels. Okay, it is a 4-inch sticky note versus 3-inch or whatever. Generally the profits and the production volumes are calculated at the product line level, that is sticky notes. So it's okay if you normalize this product table in that case, because you are not dealing with the granular data, so you can keep the granular data in a separate table which is not generally joined. That reduces the size of this table, and then that reduces the size of this join, the Cartesian product of these two. So these are some different techniques which are used, and then in that case that schema is called snowflake. So what is the characteristic of a snowflake? In snowflake, instead of one dimension table per dimension, there will be multiple tables per dimension, as against star. In star you have one table per dimension, in snowflake you have multiple tables per dimension. And then whether you have number of tables equal to number of levels or not, that depends on you again. So for example, in time you can have a table for year, quarter, month, day, 4 tables, or you can have 2 tables, one with year, quarter, other with month, day. Okay, both these varieties are still called snowflake, and that is called the degree of snowflaking. And this snowflake, actually what it adds is, it obviously adds some more time to your query. So if you have to fire a select, then there will be more number of joins. But what is the advantage of snowflake? if you are always joining to a particular level of dimension, then why join with all the rows at the granular level? So join only at that level. So that's why snowflaking is done. Okay. So if you remember from day one discussion, the entire query performance depends on number of rows and the number of tables. Okay. And in these two schemas, that is star and snowflake, we are trying to play around these two parameters. In star schema, we are reducing the number of joins, but then the number of rows is increasing. So there is a trade-off. And then if you want to reduce the number of rows, then you have to go for little bit of normalization, which can be a complete normalization or it can be a partial normalization, and that's what is achieved in snowflake. Okay. So these are two varieties of the multi-dimensional model. Yeah, and then there are three varieties of the BI server or OLAP implementation itself. They are called MOLAP, ROLAP, and HOLAP. So as you can see, MOLAP is multi-dimensional OLAP, ROLAP is relational OLAP, and HOLAP is a hybrid OLAP. Now, just by going by the names, it is already clear what these three different types of OLAP means. So obviously, relational OLAP means you store data in the relational database. Multi-dimensional means you store data in multi-dimensional database. And hybrid means you store it, and the storage is transferred to the end user. So there is a combination of both these. So OBIEE in normal sense is a relational OLAP. What it means is that our data is going to be stored in a relational database, the star or snowflake. There is no star snowflake in multi-dimensional, because in multi-dimensional the data itself is stored in a multi-dimensional array. Okay. So I think these figures will make it a little more clear. So in relational OLAP, you have got data in the relational database. Then there is a ROLAP engine or BI server, and then this is the BI presentation layer. Whereas you can compare and contrast this. So in multi-dimensional OLAP, the storage itself is multi-dimensional. It's not relational. So this multi-dimensional, it's a different type of database only. Okay. As I told you, there is Oracle SBS or Oracle OLAP. There are different products. There is a completely different product line. If you go by Microsoft, there is a Microsoft reporting services, and then the cubes which are created on top of it. In Cognos, there are Power Cubes. So there are a variety of products in this category. But relational OLAP is the configuration which is normally used by all the BI products, not the multi-dimensional OLAP. Any guesses about why it's like that? So all the BI products.
No idea.
Okay, so generally all the BI products, the OBIEE, Cognos, MicroStrategy, whatever we are going to use, they are from this ROLAP category. The basic difference between this MOLAP and ROLAP is that ROLAP stores data in relational database, and as you know, in the relational database, for accessing the data, there is a standard called SQL, Structured Query Language. So this SQL is used for creating and accessing the data in a relational database, whereas in multi-dimensional type of database, there is no SQL. Okay, so there is something called MDX, which is a non-standard interface, and not many people know about MDX. That's why this configuration is not commonly used. This is the configuration which is commonly used by all AI tools. Okay, so what this ROLAP engine does is actually converts your multi-dimensional what you call, it actually acts as a mapping between your multi-dimensional model and the table schema, and then it creates the queries and it sends it back to the data warehouse to return the data. Okay, so that is about the configurations and that is about the data model. Coming back to OBIEE, OBIEE is a BI platform which sits in between the data warehouse and which presents the data to the end user. So this OBIEE platform itself has got multiple components. So now we'll look at them one by one, and then also we'll try to see how they look like, okay, on the actual installation. So if you remember in the first presentation, I told you that in OLAP or in general in any BI tool, there are 4 types of reports that are available. One is the simple query, then there is analysis, which is also called ad hoc query. Then there is OLAP, that is the slice, dice, and roll up and roll down, if you remember. This is the enterprise reporting, which can be done in something like Crystal reports, forms. And then this is scorecards and KPIs, which are more dashboards, scorecards and KPI, which is like a concise visual reporting for the decision makers. So all these types of reporting is available in any BI platform, so it is also available in OBIEE, okay, because OBIEE is a BI platform. Now what is the difference between other platforms in OBIEE? This is based on open and what we call completely open architecture. Now what is meant by open is it's based on Java. It's not .NET based application. So the entire OBIEE is based on Java J2EE. That's why it uses a J2EE server called WebLogic behind the scenes for deploying the BI application. So you know IIS, Internet Information Server from Microsoft?
No.
Yeah. So that,
IIS, yeah, Internet Server, on which we deploy web services and websites.
Oh, okay. IIS, Internet Information Server. So that is the web server which is used for deploying your .NET, ASP, those kind of applications, right? So ASP is active server pages. So those applications, web applications are deployed on IIS. Whereas Java uses a parallel technology called JSP, Java Server Pages. And then there is something called Java Beans and Enterprise Beans, EJBs. Have you heard these terms? EJBs, Beans, etc. So our OBIEE itself is a big application, okay, which is deployed in WebLogic server. So when we install OBIEE, there are 2 parts to the installation. Installation is about the file copying. So obviously it will copy the required files into the required location, and then it deploys the web application. So while installing OBIEE, it clearly shows you 2 phases during the installation: copying files and deploying the application. So that's about how OBIEE is internally. There are some other factors like architecture is based on something called Oracle Fusion middleware and all that, but those are like more of architectural details. I am not going to those details. But in general, just to introduce the concept, any enterprise application, what is meant by enterprise application is any big application which is used by multiple users. There are certain common aspects to that application, and one such aspect is security. So if you have to use SQL Server or you have to use Windows, you have to log into that, right? You have to provide your user ID and password. Then your user ID and password has got a role, it has got a group. So all this is called infrastructural components of that enterprise application. SQL Server is a relational database, right? But still it needs security, and that security is similar to Oracle security or OBIEE security. So these are common components. That's why they are called infrastructural components. So OBIEE 11G uses infrastructural components from a middleware software called Fusion middleware. So why introducing you to all this terminologies. We are going to use this terminology when we use the application. So just try to remember this terminology. I will be using it again and again when I go to the OBIEE actual application. So OBIEE is a web application which is deployed on the logic server. Internally it uses all the beans, and then these beans actually have got business logic in C++ code. So there is a RPC communication, IPC RPC, if you remember. Inter-process communication is there between these beans and the C++ server. Now this is some terminology I don't think that is required for the time being. Just a quick thing, so you know the long form, OBIEE, Oracle Business Intelligence Enterprise Edition. Why it is called Enterprise Edition is because it is used at like multiple projects, multiple users, multiple locations. There is a parallel edition which is a scaled down version called Standard Edition. Okay. This is just a historic view. I am not going to get into that, and I'll move on directly to the application architecture. Okay, so this is how OBIEE from the outset looks. If you recall our BI architecture, this is the top layer of that BI architecture. So this you can think of as a data warehouse. Then in between there is a BI server, which is OBIEE server, and then this OBIEE server delivers the output, that is reports, dashboards, etc. through certain other applications, through portlets. There is one more interface called MS Office interface, through which you can look at the reports through MS Office tools, that is Excel and PowerPoint, or you can create your own interface using XML and API. So all these three types of interfaces are available to look at the reports. And that's why it is called hot pluggable. Okay, so it's not a hard coded. There is an API which is based on XML and SOAP. You probably are familiar with this, XML and SOAP, the web services interface. Through that you can interact with the OBIEE server and get the reports out. Yeah. So this is more of a functional block diagram. So this is data warehouse, and then this is the concept of that integration which we talked about. If there are multiple data sources, there are multiple departments, then you integrate that through ETL into this enterprise warehouse. OBIEE uses a different term now called enterprise data warehouse. Nothing different than the normal data warehouse, it is just an enterprise-wide data warehouse. And then it uses this business model. Now this business model is nothing but our multi-dimensional model, and then through this model it creates dashboards, analytics reports, there is predictive analysis, ad hoc reports. And then if you remember, there were two more functionalities which I explained on day one, that is scheduling of reports. If you want to run a report at a specific time or based on a particular condition, then that is done through this proactive and detection mechanism. Okay. And then this mechanism is actually all these, this is actually delivered to the end user through different tools. Okay. So OBIEE consists of this central server, and then there are different vertical tools to cater to different types of outputs. Okay. So if you want to look at reports and interactive dashboard, there is a tool called Oracle Answers, OBIEE Answers. Then there is a different tool called Delivers, which is used for proactive detection. So I'm just trying to give you a very high level overview of how OBIEE is. So OBIEE is a BI server which gets the data from the data warehouse, and then it delivers that data along with different vertical applications. And these are all web applications. Okay, what do you mean by web application is they can be accessed through your web server like Internet Explorer. We are going to use Internet Explorer to really get the output. Okay, then actually there are two more interfaces also in addition to web. You can look at the reports on mobile, you can look at the reports in a what do you call a different application, which is a quick client application. For that, you can use the API which is called.
Right.
Okay. And then see, once you get this data out over here, then you can build your vertical applications based on the domain. For example, you want to do sales analysis, or you want to do marketing analysis, or you want to do spend analysis, or you want to do supplier analysis, customer analysis. So based on that, you can build different verticals on top of the whatever reports you are creating. So this is nothing but a bunch of reports. Okay, and these reports can be either pre-built or you build them as per requirements. So based on your requirements understanding, you decide what reports are to be built. Yeah. So again, at very high level, this is how it looks like. This is our OBIEE and this is OBIEE. And then this is your data warehouse. This is our Oracle database.
Right.
Yeah. Now we will start getting into details of each of this. So this data warehouse, as I showed you here, this data warehouse has got something called enterprise business model. Now this business model is nothing but the multi-dimensional model of the data which is there in the data warehouse. Now every tool has got a specific method of creating this multi-dimensional model. And then there is a tool for creating this multi-dimensional model. So the tool which is used by OBIEE is called Oracle Admin. And this Oracle Admin is used for creating something called enterprise information model. And this model is in the form of a file called .rpd file. Okay. Again,
Right.
as I said, I am just introducing all this terminology. Once we start doing this, you will get used to it. But just remember that the model, multidimensional model, which is used by DI tools, that is called enterprise information model in OBIEE context, and physically that is created in the form of a .rpd file. Okay, and that .rpd file is created through a tool called Oracle Admin. So just to show you that, this is my installation. So there are different tools. Okay, this is the OBIEE Admin tool through which you create this information model. Okay, and then this information model itself has got different layers. In fact, there are 3 layers: physical layer, semantic layer, and the presentation layer. This semantic layer is also called BMM or business model layer. What is the significance of each layer, how they are used, I'll get into that. But at a very high level, physical layer corresponds to your physical schema in the database. So it maps directly to your tables, primary keys, foreign keys, etc. As I told you that in the relational database, everything is table and relation, or everything is table, key, and foreign key. Whereas in multidimensional model, we talk about dimension, hierarchies, and measure. So there has to be something in between which is going to map this terminology to this terminology, right? So when we say I have got a product dimension, you actually mean that there is a product table in your relational database with columns like product ID, product description, product type, etc. But the BI tool understands the terminology product dimension, whereas actual data is stored in a product table. So we want some kind of bridging or mapping between these two terminologies. And that bridging or mapping is provided through this layer. That is called semantic object layer or BMM. Okay. Now why this mapping is required? See, in physical layer, you have got physical tables with cryptic names. Probably you have got P_dim as a table, P_id as column, PRD underscore DESC as the column for description. So all these are cryptic column names which don't make sense from business angle, right? In business, what you say is, this is my product, this is my product line, this is my brand. So how do you map this business terminology to the database technical terminology? So that's the purpose of this layer. So in addition to defining dimensions, hierarchies and measures, it converts this terminology from a technical terminology to business terminology. Okay. Again, how it is done, we will come to that, but I'm just telling you that this layer in between is meant for that. It is a bridge layer between the physical terminology and the business terminology. Now, once the business terminology is there, you still need to have different domain related analysis. For example, in your company database, you have got hundreds of tables, you have got hundreds of dimensions and measures. Now, how do you categorize those into different categories? Okay, these tables are related to sales analysis, these tables are related to production analysis, these tables are related to customer analysis. So this kind of segregation is done at this level, simplified view. Okay, and that is called presentation layer. Also, if there is a, say, typically a project with say 100 star schemas. Now, not every developer is going to work on all those 100 star schemas. Okay, he will typically work on few, then there will be different project groups, they will work on different sets of star schemas. So one group is working on sales star schema, other group is working on customer star schema. Then how do you provide access to these people to different star schemas? That is also done through presentation there. The roles and preferences, they are set in the role this presentation. So that's how these three layers are created in the model, and these are the high level, what you call, the responsibilities of each level, each layer. Okay, and then overall this model or these three layers, they provide you all these advantages. It enables consistency, security, reuse and flexibility. All these are very generic terminologies. What is meant by consistency? You have a common terminology for business. Security, I told you about the role-based security for different project groups. Then there is a reuse. You can just deploy this model on some other BI server and reuse the same business terminology. And then flexibility is, you are disconnecting from the technical terminology. So you have got a flexibility, whether you call it a product or product line or brand, that flexibility is here. Okay. Then the rest of the things are more or less which we have talked about. Model 1 is deploy anywhere, spending data source and all that. What is important is, what is this model? What are the three layers in the model? So when we start creating reports, we use this model. We don't go to the physical layer. We don't write SQL. What we use is the business model in terms of business terminology. So we don't say that show me P underscore DSC by YR underscore whatever. We say that show me sales by product and year. And then this semantic query, show me product by sales by product and year, is converted to this actual thing in this layer. Okay. So that is how your query comes from here to the presentation layer. Presentation layer converts it to the semantic layer. Semantic layer converts it to the physical, and then it goes to the database. Then it fetches the data, it gives it back in that similar fashion, and you see those. So that is the role of this model in between. Okay.